All right, so here we have regular payments needed to achieve a financial goal. So again, we're going to deposit some p-value, some principal that must be made at the end of each compounding period into an annuity that pays an annual interest rate R. And again, we have to convert it to the decimal form, compounded n times per year in order to achieve a value of $8 after t years is given by that. So now we're going to want a future value A is what we know. We know our rate, we know our number of times it's compounded per year, we know how long, and then P is going to be how much we actually have to deposit. So this time we're calculating our payment that we have to make. If you remember before, up here, we knew how much we were paying. We knew our rate, we knew our N, and we knew our T, and we were trying to figure out what our future value was going to be. So now we say, okay, well, I want to get to this point in time. I want to have $1 million. I know I'm going to get this rate for this many compounding periods for this number of years. What is my payment going to have to be each month to get to that point? Okay, and so that's the equation we're going to use now. Now, note when computing regular payments needed to achieve a financial goal, what we need to do is round the deposit made at the end of each compounding period up. Otherwise, we're never going to achieve that goal. We'll get close, but we're not actually going to hit that goal. If we say $1 million, we might be at $999,990 or something like that. We'll be off by so many dollars. And so we always have to round up in this case. Okay. So let's do this example. So parents of a baby girl are in a financial position to begin saving for her college education. They plan to have $100,000 in a college fund in 18 years by making regular end-of-the-month deposits into an annuity that earns the equivalent of 9% compounded monthly. How much should they deposit each month, round up to the nearest dollar? How much of the $100,000 college fund comes from deposits and how much comes from earnings? And we're going to do this by hand, or do it by Excel, and we're going to do it by our calculator. All right, so first things first, we have to do it by hand. So that's going to be, we have to type all this stuff into our calculator manually. So our payment is going to be what? Well, we want to get a future value of $100,000. We're going to multiply that by our rate, 0.09. Again, we're converting that to a decimal, divided by the number of times per year, or in number of compounding periods, which is 12, divided by, and now we have our 1 plus our 0.09 divided by 12 raised to the power. Well, we're doing it 12 times a year, and we're going to do it for 18 years. So that's going to be 12 times 18, and then minus 1. And this should give us the value we have to pay each month. So let's go look on our calculator and see if we can calculate that. All right, so what we said was we have to get to $100,000, and we're going to multiply that by the 0.09 divided by 12, and then that's going to be divided by, and then we had our 1 plus 0.09 divided by 12, and we raised that to the power, and then we had 12 times 18, and we have to arrow down, and then it's going to be minus 1, and then parenthesis. Now, one thing to note I failed to mention earlier is if your calculator is an older model and you have to use the caret button here and it doesn't take it to a parenthesis like that, but you keep a caret there, you're going to have to put caret and then parenthesis 12 times 18 in parenthesis. Otherwise, it won't have this whole thing as a power like that. All right, so what does this give us? Well, this says we're going to have to deposit $186.44 to get this. So let's go back over here. And so it says we're going to have to deposit $186.44. But they want us to round to the nearest dollar. And again, we're going to round up always. And so that means we're going to have to put in $187 every month or whatever. Yeah, every month in this case. Okay. So that is part one. Part two, how much of the $100,000 comes from deposits and how much comes from earnings and interest? All right, so how much are we depositing? Well, we're taking $187 times 12 months times 18 years. And so that's going to give us what? Well, it's going to give us 187 times 12 times 18. And so that's 40,392. So that's going to give us 40,392. And we know that we had 100,000 to start with. So if we subtract that, that's going to be 8, that's going to be a 0, that's going to be a 6, that's going to be a 9, and that's going to be a 5. And so this is deposit, this is going to be interest. Okay, so interest and deposit. All right, so that's what it is. Again, doing it longhand and using all the formulas that we have to do. Now, with our TI-84, we can use the same numbers and use that solver again and figure out what we're going to do. So let's go do that. So again, we're going to do use apps. We're going to go to finance. We're going to do the solver. And now what do we have? Okay, well, in this case, we're going to have 12 times 18, which is going to give us 216 payments. Our interest rate in this case was only 9%, it said. Payments is what we're looking for. The future value, we want 100,000. We're doing monthly payments, so that works. And so now what we're doing is we're looking for our payments. And so if we do our alpha enter on the payment, it tells us we're going to have to pay $186.44, which is what we found before. And again, if we round that up, that's going to give us $187 that we're going to have to do. So that fits with what we had before. Now, what about with Excel? All right, so again, with Excel, I have a achieving a goal kind of thing. And so our goal in this case is we want to have $100,000. Our annual rate was 9%. The number of deposits per year were 12, and the number of years was 18. And it says we're going to again have to pay $186.44, or if we round that up, $187. Well, how did we find this one? Well, this time, if you notice, we did payments. So let's actually just kind of go from here. Can we make it bigger? So we have payments, so it's equals PMT. We have to put our rate in. Our rate was our 9% divided by the 12 times 100. Again, what we could have done is we could have taken a 9, converted it to 0.09. We wouldn't have to divide by 100, but we still have to divide by 12 in here. The number of payments, NPR, that's going to be how many times? Well, that's going to be our number deposits times the number of years, which is 12 times 18. Now we don't have a present value, so that's going to be a blank. So that's why we have this blank here, just blank or a comma, blank, comma. So that we don't have. And then our future value is what we want it to be, and that's our goal, and that's the $100,000. And so that's why we have what we have there. And so then we get our $186.44. Okay, so both ways we get the same thing, or all three ways actually, we get the same thing. We have to pay $187. We're going to end up depositing 40,392, and we're going to get $59,608 off of interest. Okay, so let's stop there and we'll come back for more.